All right. Hello, everybody. No general meeting today. Instead, I'm on video. It was Sunday when I realized that it's Veterans Day. Um, and I wanted to introduce this kind of pseudo workshop. It's going to be different than the electric motor workshop because in the electric motor workshop, we were dealing with kind of inert materials. So I was comfortable assembling them on campus, but this time we're dealing with lithium ion cells and those carry some risks. So we're just going to play it safe and uh, take the assembly to my house, which is close to campus. You guys are welcome to come over. Just don't be weird, please. Before you participate, you need to design the pack holder. So this is not a SolidWorks instructional video. I'm just basically going to quickly go over what your cell holder needs to do, um, some dimensions that you'll need to know. Let's talk about the requirements that I'm kind of looking for. You need to constrain the cells vertically and horizontally. Your pack holder needs to protect the cells. Here, the 3D printed cell holder, you can see like it's protecting the cells. I need to you kind of push this down and it inserts the cells, but you're protecting the cells from physical damage. And you're also keeping the bus bars inside the profile of the case. Optionally, you can add things like air gaps inside of the pack or like maybe small cooling holes. It's not necessary probably for the ways you're going to be using this pack, and you could design stuff like a cover for the XT90 connector. And if you don't know what an XT90 connector is, Google it. Um, this is the pack that I designed. It's 4S1P. This is the configuration I landed on. This is kind of, if you don't know what configuration to pick this one. It's um, small and high performance. A 4S 1P configuration, and we're using 21700 M50LT cells. Now that I know the configuration and I know the cell, I could tell you a lot about how this pack is going to perform. Um, we know that the nominal voltage for a 21700 cell is 3.7 volts. So we take 3.7, multiply it by our series count. We get a pack voltage of 14.8 volts. And we take the continuous amp reading for these cells. It says right here it's 10.3, 10.3 amps times our parallel count, which is 1. We get 10.3 amps. If we remember Ohm's law, power is equal to volts times amps, which is 10.3 times 14.8. I think this is around 152 watts. It's pretty good. Um, if you want to go with a different configuration, you can. Let's try to keep it under 12 total cells. Um, this is the method we're going to be connecting the bus bars together. This is spot welding. This is good. This is bad. This is very bad. Immediate recycle, whoever did this. They soldered a wire directly to the negative terminal of this can. That is, no, automatic recycle. That gets the cell super hot. It could damage the internals of the cell. It can catch on fire. Very bad. Automatic recycle. We use spot welding. Path. So here we have our battery global high and our battery global low. So let's follow high to low. First, we're going to have a bus bar that comes kind of down here, and we're going to solder the terminal wires to the bus bar, not to the negative can. We're going to have the bus bar spot welded on here, and then we're going to solder over here away from the cell. So we start here at the low. We go global low, low to high. Now we're here, and we go high to low. And then now we're here. We go up, low to high. Now we're here, high to low, low, other side, down to here, high to low, low to high. Bang. That's our bus bar configuration. This alternating pattern that I have is probably the best form factor. If you want to do it in a different way, if you want to have them all connected in a line, be my guest. Let's talk about the dimensions. So The dimensions of these 21700 cells, I'll post an image, but basically it's in the name. The diameter is 21 millimeters and the height is like 70, but really it's like 71. When you're designing the holder, you want your you want to constrain them kind of like this, these little peg holes, and the diameter of the holes that I used are 22 and a half, 23 millimeters. Honestly, I'd go with 23. You want to kind of upsize a little bit so that these holes are not too small because it's easy to add material to get it to be a snug fit. This height right here, I use 7.5 millimeters. That's the depth of this hole. If we go back to the total section view, this is what the top and bottom looks like. So the tops of this case are kind of constraining the cells vertically. You can see here that these cells are constrained in this direction and side to side. In the peg, you put the two halves together, they slot in. In terms of keeping these two halves connected, I'm going to use tape. Yeah, I'm going to use tape. If you want to do something fancy like a little slot for your 3D print to slide together, or you want to do threaded insert, I have some threaded insert materials. I'm going to use tape because I can, and tape's good. That's pretty much it. See you guys in 2 weeks.